Hello. In this tutorial, I will be discussing one very exciting online resource for carrying out space weather modeling. One of the more exciting features of this resource is that it's available publicly, meaning that anybody who is interested in carrying out space science and space weather modeling can access the resource. And the resource is called Community Coordinated Modeling Center. So let's go now from the integrated space to the analysis system that I'm using always first actually analyze the real-time space weather to the ccmc resource. So the URL for this thing is ccmc.gsfc.nasa.gov. Okay, and that will bring us to the in the home page of the Community Coordinated Modeling Center, ccmc. Now the cool thing with ccmc is that these guys host a very large number of state-of-the-art space sciences and space weather models developed essentially by the international space weather community. The models that ccmc hosts can be quickly browsed through clicking Models at ccmc link, then ccmc Models at glance. And once you start browsing through here, you will see quickly that ccmc has models essentially for all central space weather domains, starting from solar models to moving to heliospheric models. These are both physics-based numerical simulations type models and also empirical models. Then ccmc has magnetospheric models also for the ionosphere, thermosphere. So really a vast collection of large-scale space weather models available for the entire international space weather community. Okay, so definitely go into the ccmc website and then start exploring these models. They're a really cool resource to have for you to start carrying out quite heavy, large-scale numerical space weather simulations. What I will next demonstrate is that how you can actually request a simulation through ccmc resource. Okay, so let's say we're interested in carrying out simulations of coronal mass ejection propagation in the interplanetary medium. So let's see, for example, we would be interested in looking at NL model with cone models. So all the other models have more detailed pages here where you can get more detailed information about each individual models, and then also links and to more detailed descriptions and links to central science peer-reviewed papers where you can find all the scientific details pertaining to individual models. Okay, so we want to carry out a simulation or CME simulation. So let's click request a run. And now the process that I will be showing here is quite universal for requesting any type of a simulation through ccmc. So once you learn the process for requesting simulations for one single model, that same general philosophy or general flow of requests applies also for other models hosted at ccmc. So we were interested in carrying out CME simulation. So let's use the NL model, which is a three-dimensional model of the heliosphere, together with so-called cone model that enables us to introduce CMEs at the inner boundary of NL. Okay, so here you can click more details about the model. Maybe then you can click also instruction about the actual model a requesting process, but we can just go ahead and start going through the request process. So in the first page you will provide some basic information for the ccmc folks. Your name. Let's just put tests here. Test let's say org in this case. You can run a request 4 runs per day, so that's why we have the ccmc folks have this pop-down menu. Then you can put some keywords describing what type of run or what type of analysis you're doing with this run. Then we have a selection to generate stationary background SolarWind solution or to run NLL with cone model. We want to run with cone model because we want to do CME simulations. Then let's click continue. And then we start to build boundary conditions for the simulation. For in the case of NL, there are different inner boundary conditions. MAS can build a coronal or solar atmospheric solution that can be then fed into the NL simulations. We will use Wangeli RGNL, which is kind of a semi-empirical model to provide the inner boundary conditions. Then you have to specify which Carrington rotation you're interested in. I'm not going to go into details of discussing what that is. It's not important for the purpose of this tutorial. We can use different magnetograms to provide or to build the inner boundary conditions. So let's use Gong Observatory to build that information. And then you can start to look at the grid definitions here. We want to solve everything, let's say that in this case all the way up to 10 AU. Okay, the standard default setting is just 2 AU, but let's now in this demonstration request a run that goes all the way up to 10 AU. Okay, and then you can when you do CME simulations with this cone model, you can actually introduce a number of simulations into number of CMEs into one single simulation, and these clouds can actually then interact within the simulation itself. Okay, this is really a cool feature as well. Now let's just check one cloud here, one CME in this case, and press continue. And that bell gets us to the final page where we provide information about the properties of the fast wind. Again, part of the inner boundary conditions for the simulation. We're not going to go into details here. We're just going to be satisfied with the default settings, which usually are pretty good in the ccmc resource. And then we'll define the actual cloud that we're going to. We're going to define the CME parameters that we introduce in the inner boundary of the NL model. So let's say I'm doing this tutorial August, what is today? August 26. So let's assume we had CME today and we're interested in modeling that. So let's put August 26. I'm not sure if the actually Carrington rotation map is already available for this. So let's just for the sake of demonstration request something from previous year, August 26. Cloud. Let's assume that the cloud reached the boundary at 21.5 solar radii. Let's say 447 UT time. Latitude of the cloud was 20 degrees. Longitude, let's say it was backsided, so minus 180 degrees. The radius of the cloud. All these parameters are described more in detail in the individual model page, where you can find all the dirty details. Let's say cloud radius, just for the sake of demonstration. Let's say this is pretty wide, 60 degrees, and this was really fast, so we're looking at kind of a major CM events. Let's put this over to the 2600 kilometers per second, and then use the density enhancement factors and those kinds of things. Just what are the default settings provided by ccmc. Okay. And then, the final task is to set the simulation grid, what type of spatial resolution we want to resolve with the simulation. Let's just, for the sake of argumentation, select the sort of a middle level resolution, and that's really sets up everything for a completed request. So we have selected the model boundary conditions. We have defined the grid that we want to use in the simulation, and we are ready to submit the request. So after you press this continue, which we are not going to do here, we don't want to submit these kinds of test runs to ccmc to add to their computational burden. But once you press this continue, that sends this information and builds a new entry to the queue in the simulation database at ccmc, and depending on the size of a simulation you're requesting, within few days usually you will get a reply back from ccmc to the email address that you provided here, indicating that your simulation has been completed, and then you're able to start looking at the actual results. For example, using the visualization interface, also available through ccmc, or you can actually request also the raw numerical data from the simulation if you want to start looking more in detail the behavior of for example, the CME in the simulation using your own tools. But that visualization process, for example, through ccmc interface, we will be discussing more in detail in part 2 of this tutorial. So, in summary, ccmc Community Coordinated Modeling Center. This is a really cool resource if you're interested in doing large-scale space weather simulations and don't necessarily have access otherwise to these models or computational resources that are required for these types of simulations. So definitely go and check out what ccmc has to offer to you.